This is the addition method from our homework. We're going to go over the odd problems. Let's recall a little bit about what the addition method actually is. If we have one equation where we have a triangle equals a square, a left side equals a right side, and we have a second equation, let's say we have a happy face equals a heart, right? Then what we can do is add the left sides together, and then that equals the sum of the right sides. And the whole idea here is to eliminate a variable. Either the x variable or the y variable. So this addition method, where we add the two left-hand sides together and we set it equal to the sum of the right-hand sides, the whole purpose and idea is to eliminate a variable. Now, if we notice here that if we add the left side here with the right side, what we end up getting is 2x plus x gives us 3x. The plus y and minus y cancel. That's the sum on the left sides. So if you're looking at what we're doing on the left sides, we're adding these two terms with these two terms. We end up with a 3x. And on the right, we're going to add the 3 with the 3, and we end up here with the 6. So take a look here. We're adding the left sides together. We set them equal to the sum of the right sides. What we end up with is a nice equation that has to do with a single variable to solve. We get 3x equals 6. We can solve this by dividing both sides by the number 3. We get cancellation. Now x is the value 2. So this is the essence of the program here, or the approach that we're going to use, called the addition method. And the whole idea here is to actually eliminate a variable. Let's go do this again. We're going to use this addition method right here so that we can eliminate a variable, either the x variable or the y variable. In this first example, we eliminated the y variable. Now what we use here is going to be, let's put this in red, we're now going to use what we call back substitution. Okay, back substitution, meaning I have the value x is 2 right down here. X is 2. I'm going to plug back into my original equation, either the first or the second. It doesn't matter. We're going to plug back in the value x is 2, and we're going to get two equations here where I have 2 times 2, which is 4, plus y is 3, or I have 2 minus y is 3. So I can now find the y coordinate value by solving one of these equations. They both are going to give me the same answer. So we either choose the first or the second. I'm going to choose the first equation. 4 plus y is 3. That looks to me to be a lot easier to solve. So I have 4 plus y is 3. We're going to subtract 4 from both sides, and we end up getting y equals 3 minus 4, which is negative 1. So here's our answer. X was the value of 2. And we found y to be the value of negative 1. This here is our point of intersection for the first problem. We're going to use this technique called the addition method, also known as the elimination method, to solve a linear system of two equations and two unknowns. We're going to do this throughout our homework. Now the rest of the problems I won't go into this detail, but this was the idea that was discussed in lecture, and now we're going to actually go through and do the rest of the homework, or at least the odds. I have x plus y will be -4. I have x minus y is +4. We're going to use the addition method here. Add the left sides together and set it equal to the sum of the right sides together. So, if we look at what's going on, x plus y plus x minus y. X plus y plus x minus y. That's going to equal, let's look at the other side, -4 plus 4, or we should say 0. So let's simplify our equations here. We get 2x and my y variable is gone. -4 plus 4 will give me a 0. So let's go through this. X plus x is 2x. Positive y and negative y is 0. -4 plus 4 is 0. I'm going to divide both sides now by 2. And I end up with x equals 0. Because 0 divided by 2 is 0. I'm going to now use back substitution to determine the y coordinate value. So we notice x is 0. Plug in 0 for the value of x in either of our equations. Now I'm going to use the first equation again and show that y here, or I should say 0 plus y, is -4, and then 0 plus y is simply y. I found the y coordinate value here to be -4. The point of intersection is 0, -4. This is our solution. Number 5. X plus 4y is -3. X minus y is +3. We're going to add our left sides together and set it equal to the sum of the right sides together. So on the left, I have x plus 4. It's going to be added to a -x minus y. X plus 4y minus x minus y. And on the right side, I have a -3 plus a +3. -3 plus a +3. Let's simplify. On the left side, the x and the -x cancel. Then I have 4y minus y. This gives us a nice 3y. And that's equal to -3 plus 3, which is 0. Divide both sides by 3. We solve this equation for y. We find that y will be 0. We're going to use back substitution. Use back sub to obtain the x coordinate. So y is 0 here. I'm going to use my first equation. I think that's easiest. I find x plus 4 times 0 is -3. 4 times 0 is 0. X plus 0 is just x. My x coordinate is -3. -3 comma 0 is the solution to the first equation. Number 7. 3x minus y is -2. X plus 2y is -3. We're going to use the addition method so that we can eliminate a variable. So on the left side, let's take, because this is minus, let's double check here. Yes, on the left side here, we're going to add 3x minus y with x plus 2y. So we get 3x minus y plus x plus 2y on the left, and that will equal -2 plus -3. And when we combine our like terms on the left side, we notice we get 4x plus y is -5. Now here's a problem. We didn't get elimination. The x variable wasn't eliminated, nor was the y variable eliminated. We need to eliminate a variable. So we're going to have to start over. Meaning, I have 3x minus y equal to -2. X plus 2y is equal to -3. Now there's two things that we can do here. We can actually multiply the first equation by +2. So if I multiply here my first equation by +2, notice what we get here. We're going to have to, of course, distribute that 2. So a new first equation that we get now becomes 6x minus 2y equals -4. The second equation is still x plus 2y equals -3. Now the reason we chose the -2 value, or I should say the +2 value, to multiply to that first equation is so we can eliminate the y variable. You see, -2 and +2 are opposites. Whenever a variable is eliminated, it's because the value in front of the variable, or we should say the values in front of the variables for both equations, are opposites. The opposite of a -2 is a +2. The opposite of a +3 is a -3. The opposite of a +5 is a -5. When you have these opposites, you will have cancellation when you use the addition method. A variable will be eliminated. Now notice, 6x plus x gives you 7x. But the -2y plus 2y, the y variable was eliminated here. We just now have to add the values on the right side, which is -4 plus a -3 being -7. So we're going to use this approach whenever a variable is not eliminated. We're going to take advantage of opposites for a variable. And you're going to see how this works. We discussed this in lecture in great detail. We could have actually eliminated the x variable by multiplying the second equation by -3, but we didn't. So we're going to use this approach so that we can solve our system. And we talked about it in a lecture. So let's finish this problem, and we'll discover that x is going to be -1. We're now going to use back sub. So because x is -1, we need the y coordinate. So let's use back substitution. We're going to plug in a -1 for our equation. Now, we can plug in -1 in any of the equations. I'm just going to plug it in either the first two and see which one is easiest. Maybe the second equation is easiest. That's going to give me -1 plus 2y equals -3. We're now going to solve for y. We're going to add 1 to both sides. We get 2y is -2. Divide both sides by 2. We now get y being negative 1. So the x-coordinate's negative 1 and the y-coordinate's negative 1. We are done. Number 9. X plus 4y is 5. X plus y is negative 7. If you notice, if we add the left sides together, again, we have no variable that's eliminated. So we're going to need to obtain opposites for the x values, the x variable, or the y values, the y variable. So it looks like what we can do here is multiply the top equation by negative 3 so that I get a negative 3x that will be opposite to the 3x in the second equation. Don't forget to distribute. My new first equation is negative 3x minus 12y is negative 15. The second equation is 3x plus y is negative 7. Let's add. Notice we have opposites here, meaning really the negative 3 in front of the x and the positive 3 in front of the x for the second equation are opposites. We're now going to get negative 11y equals negative 22. The x variable was eliminated. Divide both sides by negative 11. We obtain y equal to a positive 2. We're now going to use back sub. Now, back sub says plug in 2 for the y coordinate or the y variable in either equation. What you end up with is 3x plus 2 is negative 7. You can subtract 2 from both sides. We get 3x is negative 9. Divide both sides by 3, and you'll find that the x or the 3's cancel here, and that the x value will be negative 3. So my point of intersection is negative 3 comma positive 2. And you're done. Number 11. 3x plus y is negative 11. X minus 2y is positive 8. If I add the left sides together, again, we see that there's no elimination. Let's multiply the second equation by a negative 3. This will give us opposites for the x-coordinate. Let's take a look at what we have. The first equation remains unchanged. The second equation is now negative 3x plus 6y, and that will equal negative 24. Don't forget, you distributed the multiplication with negative 3. Now, by adding the left sides together, we get 7y equal to negative 35. We're going to divide both sides by 7. And y is going to be negative 5. At this point, we use back substitution to find the x-coordinate. So plug in negative 5 for y. The first equation becomes 3x minus 5 is negative 11. We're going to add 5 to both sides, and here's what we end up with. 3x is negative 6. Divide both sides by 3, and you're going to find x to be negative 2. Negative 2, comma, negative 5. This is my solution. Number 13. 2x plus y is 9. 3x minus 5y is 7. If we use the addition method, we'll notice that nothing will be eliminated. 2x plus 3x is 5x, plus y and a negative 5y is a negative 4y. So we're going to multiply the top equation here by 5. This will give us opposite values for the y coordinate. Let's see what the first equation becomes. 10x plus 5y is 45. We have 3x minus 5y will be 7. Now 10x plus 3x gives us a 13x, a positive 5y right in here, and a negative 5y. These are opposites. Get rid of the y variable. It was eliminated. And 45 plus 7 gives us 52. We're now going to divide both sides by 13. We end up with x being 52 divided by 13 is 4. We get to now use back substitution. For x, replace it with a 4. And we can put that really anywhere again. So I'm going to use the second equation now. And so we have 3 times 4 minus 5y is 7. Or 12 minus 5y is 7. We're going to subtract 12 from both sides. We get negative 5y is negative 5. Divide both sides by negative 5. We get y equals 1. 4, 1 is our point of intersection. Number 15. 3x plus 2y is negative 4. 2x plus 4y is negative 8. If we add the left sides together and add the right sides, or just adding the left sides, notice you don't get elimination for a variable. 3x plus 2x is 5x. 2y plus 4y is actually 6y. So a variable was not eliminated. We're going to have to fix one of the equations. Let's multiply the first equation by negative 2. Negative 6x minus 4y is positive 8. My first equation stays the same. Notice for the y variable, we have opposite values here. So that the addition method, when I add the left sides together, we'll have the y variable eliminated. Negative 6x plus 2x is negative 4x. 8 minus 8 is 0. We can solve this equation. Divide both sides by negative 4, and we get x equal to 0. We're now going to use back substitution. Plug in 0 excuse me, wherever there's an x variable. I think I'm going to use the second equation here. It looks like it's easiest. I know that 2 times 0 is going to give me a 0. I got 4y minus 8. So 2 times 0 is 0, so this is gone. I just have 4y minus 8. Let's divide both sides by 4 here. We're going to get y equal to negative 2. So the x-coordinate is 0, and the y-coordinate is negative 2. Number 17. 4x minus 2y is negative 6. 3x plus 5y is positive 2. Now in this question here, number 17, if we add the left sides together, we get 7x plus 3y. We have no elimination. So we're going to have to fix this. Now this is a little bit more sophisticated to fix. Here's what I want to point out what we're going to do. The first equation, if we decide, for example, to eliminate the x variable, let's eliminate the x variable. Let's remember, in order to eliminate the x variable, we have to have opposites for the values multiplied to the x variable in both equations. You know, the opposite of a 15, which is positive, is negative 15. The opposite of a negative 4 is positive 4. Opposite of a 7, a positive 7, is negative 7, and so on. So we don't have opposites. We have a 4x and a 3x. So here's what we're going to do. We're going to consider we have the 4 here. Let's multiply the second equation by a 4. And we're going to multiply, let's take a look here. The second equation has a 3 in front of the x. We're going to multiply. Now we're going to take this 3 or use that value, and we're going to multiply the top equation by 3. Now notice what this does for us. 3 times 4x for the first equation is 12x, and 4 times 3x for the second equation is 12x. They're not opposites, so make one of them negative, maybe the first one. And so what you're going to get now is the following. Negative 12x plus 6y, because you are distributing here and here. That will equal negative 18. The second equation, 4 times 3x is 12x as well. And then 4 times 5y gives you 20y. 4 times 2 is 8. We now have the opposites that we're looking for the x variable. Negative 12 and positive 12, these are opposites. So this is a trick that we use to guarantee that we'll get opposites. We just use the corresponding coefficients for the x variables, or the y variables if you choose to get rid of y. Now, by the addition rule, notice again, the x variable is eliminated. We have 26y equal to 10. Now let's double check everything to make sure that we did things right. Negative 3 times 4, negative 3 times positive 2. Here's the question. Here's the problem. Let's take a look. Found something. This is negative, which makes this positive, which makes 18 plus 8 actually 26. So be careful. Let's highlight this. Negative 3 gets multiplied to both sides. Make sure you do that, and make sure you do the appropriate arithmetic. Now this makes this question a lot nicer to answer. y is the value 1. Use back sub. Wherever there's a y, we replace it with a 1. So we can use any equation now. I think I'm going to use the first equation, negative 12x plus 6 times 1 is 18. I'm going to use this first equation over here. And this gives me negative 12x. I'll write it down here. Negative 12x plus 6 is 18. Okay, so let's go back. I use this first equation. Let's change the color. I use this first equation here in my back substitution. Subtract 6 from both sides. We get negative 12x is positive 12. Divide both sides by negative 12. We end up with here x equals positive 1. And we're done. 19. 5x plus 3y is positive 2. 2x minus 4y is positive 6. If we decide to eliminate the y variable in this case, let's try this out here. Let's notice this 3 is multiplied to y. So I'm going to multiply the second equation by that same exact value, by that 3. Now, what I'm going to have to do with the second equation, we'll notice here that I have a negative 4 multiplied to y. Well, I'm going to multiply the top equation by that 4. And it's going to have to be, well, let's double check. We don't have to do the opposites here. Don't forget, we're going to distribute. You see, the signs are opposite already. So let's actually go through the distributive property here and see what our new equations become. 4 times 5x is 20x. 4 times a positive 3y is plus 12y. 2 times 4 is 8. That's the first equation. The second equation is 6x minus 12y, and that'll be 18. We have opposites already because the signs were already opposite to begin with. So positive 12 and a negative 12. These will be eliminated, or at least the y variable will be eliminated. We get 26x equal to 26. Divide both sides by your 26. We find that x is positive 1. We're going to use back substitution to find the y value. Use back sub. X is 1. Okay. I'm going to use the second equation here. Let me find it. I'm going to use this equation here. So that means I have 6 times 1 minus 12y will be 18. Now 6 times 1 is 6. 6 minus 12y is 18. We're going to subtract 6 from both sides. We get negative 12y is positive 12. Divide both sides by negative 12. And we get y being negative 1. X is positive 1, y is negative 1. This is number 19. 21. 4x plus 3y is negative 2. 3x plus 2y is negative 1. Now, we'll get rid of, let's get rid of the x variable. And we're going to do the same, have the same approach here. Let's notice there's a 4 here, so multiply the second equation by the 4. And then there's a 3 here. Gotta be careful. When you notice there's a 3 down here, we're going to multiply the top by a 3. Use the distributive property. One has to be opposite. Let's make it the first one. Now we're going to distribute here, like down here. Let's see what we get. Our new equations. Negative 12x minus 9y is negative 6. 12x plus 8y is negative 4. We're going to add negative y is negative 10. Don't forget, divide both sides by negative 1, so we get cancellation. And now y will be negative divided by a negative, which is a positive. We're going to use back sub. Y is 10, so I can plug in 10 for any y value in any of my equations. I'm again going to use that second equation. Okay, maybe instead of highlighting, I'll just go back here and show you that I get 12x plus 8 times 10 is that negative 4. 12x plus 80 is negative 4. We're going to subtract the 80 from both sides. And we get 12x equal to negative 84. Getting down at the edge is hard to write. Divide both sides by 12. Cancel, cancel. We get x equal to 84 divided by 12. That looks like a negative 7 there. Final answer. Negative 7, positive 10. Let's see, we got now number, let's see which this one was. We did 21. Yeah, number 23 here. We have 6x plus 2y is 2. I have 4x plus 5y is 16. Well, let's try this out here. Let's eliminate the y variable. You got a 2, so we're going to multiply the bottom by 2. We have a 5. Oops. Let's try it again. We got a 5. We're going to multiply the bottom by, or the top by 5. So we can get opposites. Now they're both positive, so one has to be negative. Let's make the top one negative, and we will distribute. And let's see our equations. Negative 30x minus 10y is 10. And then I have an 8x plus a 10y is 32. The addition method. We get negative 22x is 42. We're going to divide both sides by the negative 22. Let's double check here. 6x plus 2y is 2. 4x plus 5y is 16. Okay. Negative 30 minus 10y. We did it again. Be very careful. We did that again. Make sure we got a negative. That makes this a negative 10. And that makes this a negative 22. Okay. Let's divide both sides by negative 22. Cancels. We get x is positive 1. Be very careful. Make sure they're both negative. That makes this a negative. Right, we're going to use back sub. We're going to plug x being 1 into our equations. I'm going to use that second equation again. Use this one. That gives me 8 times 1, which is 8 plus 10y, and that'll be 32. I'm going to subtract my 8 from both sides. Looks like we are not so careful today. Not so careful. X is actually negative 1. Okay? Go back. It's going to change a few things. So if x is negative 1 here, the reason x is negative 1 is because negative 10 plus 32 is positive 22. And now when I go use back substitution, I get actually a negative 8 here because I got 8 times negative 1. And that's going to be equal to 32. Okay, no big deal. Let's solve for y now. We're going to add the 8 to both sides. And we end up with here 10y being 32 plus 8 is 40. Divide both sides by your 10. And you get y being what value? Y is 4. Okay. X is negative 1. Y is positive 4. And you're done.